Hi students, we're going to do Unit 4 review. I am going to go problem by problem, and these will match the problems in Think Central and in your Fat Cheetah practice test. So if you have trouble on any of them, you can follow the video and try and figure it out. Take a look at the number 1 in Fat Cheetah. We have A through F, and we have to solve them and put them in the category of either equal to 43, 430, or 4,300. And we have exponents here. Now an exponent tells us pretty much how many zeros we're going to put on that number. So this has a 2, so I'm going to write 43 with 2 zeros. 43 with 2 zeros will be 4,300. Okay, I just added 2 zeros. So A will go here. I'm going to take a look at B. This has 1 0, so I'm going to add my 43 and 1 0. So B will go here. When I look
if you're
at
freaking
C, I
out
have a
right now,
decimal
don't
point
freak
here.
out. I know that I wrote C wrong. I'm going to correct it in a little bit. Don't worry.
3 zeros. Well, because I have the decimal, and here when I don't see the decimal, I am moving my decimal over 2 places, 1, 2, and I am moving my decimal 1 place, 1, right? And I see the decimal, I'm going to move it 3 times. So if I have it here, I'm going to move it 1, 2, 3, and fill those zeros in. So it looks like C will be 4,300. Again, I have a decimal right here, and I have 10 to the 2nd power, which means I'm going to move my decimal over twice. 1, 2. So that will make it 43. Okay. Here, I'm going to move my decimal once. It's right here. I move it once. I have 43 again. So that is E. And my last one, I'm going to move my decimal 3 times because it's 10 to the 3rd power. I'll rewrite that so I have room. 1, 2, 3. So it looks like F will go in the last category. Okay, hold on. I wrote this wrong. If you're following in your book, this is a 2. So if that's a 2, I'm going to move this 2, my decimal 2 places over, 1, 2, which would get me 430. So that's where C goes. I wrote the exponent incorrectly. So this is this problem. All right, let's take a look at number 2 in Fat Cheetah. We have Hakeem, and he's putting $59 from each paycheck into his savings account. He's getting paid every 2 weeks, or for 26 times for the whole year. And his goal is to save $1,500. Will he reach his goal? And then we have to explain that using words, drawing a model, and then writing an equation. So let's take a look. I know that if I have $59 that I'm saving every 2 weeks, or for 26 times for the year, I'm going to multiply 59 and 26. I'm saving $59 26 times for the year. So I'm going to multiply that out. 9 times 6 is 54, 6 times 5 is 30, plus 5 is 35. X out my 6. When I write an X, I should write a no as a placeholder. And then erase the other numbers that went with the number I X'd out. 2 times 8 is 18, 2 times 5 is 10, 1 more is 11. I will add these 2 together. 8 plus 5 is 8, 9, 10, 13, 3, 4, 5, 1. Okay, so looks like he will save at the end of the year 1,534. So will he reach his goal? Yes. So I'm going to explain using words. Yes, Hakeem will reach his goal because I have to explain. Explaining means you need the word because. Because 59 times 26 equals 1,534, and that is more than 1,500. Now I have to use a model. 50 plus 9 and 20 plus 6. Could do that. So I'm multiplying here 20 times 50, which is 5 times 2 is 10. Then 2 more zeros. Fives are tricky. because I know that there's only 2 zeros there, but there's 3 zeros in the product because 5 times 2 is 10, right? This is 20 times 9, and that's 18 plus a 0. This is 50 times 6. Again, don't get tricked with that 5. 5 times 6 is 30. There's a 0 already in the product. Then I add that other 0, that's 300. And then 6 times 9 is 54. So I have 1,300, 180, and 54. When I add those up, I will get the same answer I got last time. So there's my model and my equation would be 59 times 26 equals, and we can write G for goal. Will he reach his goal? All right, on number 3, I have to choose one factor in each column so that the product has 3 zeros, which means I have to choose something from here and something from here so that when I multiply them, the answer, the product, has 3 zeros. Okay, I know that I can count my zeros and get 3 zeros. For instance, if I multiplied 2,000 times 4, there's 3 zeros here, and 4 times 2 is 8. The answer would be 8,000. So 2,000 times 4 would be one answer. I could be done. I'm going to go through and find all the answers. This is one possible answer. One possible answer right there. Let's find another possible answer. I need 3 zeros. Let's see. There's 2 zeros here, which means I would need 1 0 here, and that would make 3. So 200 times 40 would get me 3 zeros. Again, that's 8,000. This also would be 8,000. Let's find another possible answer. So we have these two that will work. We have these two that will work. Let's see. Oh, I see this one, 20 and 400. That could work, right? 20 has 1 0. 400 has 2 zeros. Together, they have 3 zeros. And let's see if anything else would give me something that has 3 zeros. That decimal I don't think will work. I would need to have a third zero. So I think these are the 3 possible answers. On the test, you have to choose one. Right now, I give you 3. Let's try number 4 now. Let's take a look at number 4. We have to choose all the answers that are correct. So I'm going to solve these problems. 6 times 3 is 18. 18 with 3 zeros. Yep, 18,000. A is correct. When I look at B, I have 8 times 3, which is 24. And then I should have 1, 2, 3 zeros. I only have 1, so B is not correct. 27 times, I'm just going to look at this as a 1. So 27 times 1 is 27, and then I should have 2 zeros, which I do. So C is correct as well. When I take a look at D, I have 6 times 1, which is 6, and then I have 2 zeros here, but I have 3 zeros in the product, so that's not correct. So it looks like A and C are correct for number 4. All right, students, let's take a look at number 5. We're going to find the products of 260. So we're going to take a look and find answers that equal 260. In A, my decimal point is right in the middle, and 10 squared means I will move my decimal twice. So I'm going to move it over twice. 1, 2. That would get me 260. So that answer works. Here, if you don't see the decimal, then it says 26 times 10 to the third power, then that means it's at the end. If you don't see it, it's at the end. So I'll put it at the end and move my decimal over 3 times, or just add 3 zeros, right? 1, 2, 3, and I'm adding 3 zeros because I know that my decimal was at the end, and that is too big, so B will not work. Let's take a look at C. I have a decimal place right there, and 10 to the third power. So in this case, I'm not just adding 3 zeros because my decimal place is in the middle of my number. I'm going to move my decimal 3 places, 1, 2, 3, and that would be 260. So it looks like C works. 26 times 10 to the first power means I'm going to move my decimal place over once, and that's 26, and that's not the same. 26 times 10 to the second power, I don't see my decimal, which means it's at the end. So I'll add 2 zeros, and that will be 2,600, and that's also too big. So A and C are the only two that work for number 5. We're going to skip number 7, 6 and 7. Those are not going to be on the test, so you do not have to practice those. They're also not on the practice test, so you don't have to practice them right now. Let's take a look now at number 8. Looking at number 8 in Fat Cheetah, we have to order these from least to greatest. So the smallest number, the smallest answer, the smallest product to the greatest product. So let's go ahead and find the answers to all these problems. Because I see all these zeros and these decimals, I know I'm just going to add, multiply the two terms and then add the zeros. 5 times 3 is 15, and I'm going to add 3 zeros there, so that's 15,000. 3 times 5 again is 15. Oops. 3 times 5 is 15, and I'm going to add a 0, so that's 150. Now I have 2 decimal spots, right? So when I multiply, I take the decimal out. 1, 2 to take it out. 5 times 3 is 15, and 1, 2 to bring it back in. 1, 2. So that answer is 15 hundredths. So far my smallest one. This one again, 1 decimal place to take it out. Now I have 50 times 3. 5 times 3 is 15. Add a 0. 1 decimal out, so 1 to come back in. Looks like that answer is just 15. And this one, 5 times 3, which is 15, and I'm going to add 2 zeros to that. So when I look at this, the smallest number I have is this one. Now I'm putting the terms in order. So it would be 5 times 0.03 is the first one. That's the least. Then after that, I'd say is 15. 50 times 0.3. After 15 would be 150. 3 times 50. After 150 would be 1,500. So 300 times 5. And my last one would be 500 times 30, and that equals 15,000. So this is an order from least all the way to greatest. Let's take a look at number 9. So this would look like 8 times 10 to the third power, or it would also look like 3 zeros, 8,000. So we're looking for one of these answers and finding all the ones that apply. Okay, 8 times 10 to the second power. No, we said to the third power, so that wouldn't work. A is not out, doesn't work. When I look at B, I have 80 times 10 to the second power. That gives me 2 zeros, and this one gives me a third 0, which would give me those 3 zeros, so B will work, okay? And if you wanted to see that, that looks like 80, and then I add the 2 zeros. So that adds up. This one is 8 times 10, and then 2 zeros. That one's not right. 8 times 3, 10 to the 3 power, we did say that that would work. I write my 8 and my 3 zeros, so C definitely will work here. Looking at D, I don't want you to get confused. This says 3 times 10, which is 30. That's different than 10 to the third power. 10 to the third power is 1,000. Means like a 1 with 3 zeros. So D will not work. Here I have 800 times 10 to the 1 power. So I would write 800 and then add my 1 extra 0. So I think E will work in this equation because it would give me 8,000. And on this one, 8 times 100 would give me 800, and that would not work. So B, C, and E will give me a product that's the same as the first thing they gave me. Okay, for number 10, it seems like a pretty easy problem. It says that there's an atlas moth and its wingspan is 11 inches. So that is for one atlas moth. They want to know what the wingspan would be for 26 atlas moths. So I would multiply these two numbers together. And 6 times 1 is 6. 6 times 1 is 6. Done with that 6. Whenever I write an X, I write an O as a placeholder. X's and O's. 2 times 1 is 2. 2 times 1 is 2. I'm going to add these two together. So it looks like 26 atlas moths would get you a wingspan of 286 inches total. For number 15, we are going to try and describe how digits shift when you multiply by 1/10. So if I multiplied something by 1/10, when I multiply by a fraction, it becomes smaller. And 1/10 of it means, for instance, if I had the number 5, and I multiply that by 1/10, the 5 would move one space to the right. It would move there, and it would be 5/10, okay? So if I had to write this out, I would say the digits move right one space, okay? That's the problem for number 15, but I just want to extend it a little and show you that if the problem then said, describe how digits would shift when you multiply by 1/100th, well, and I still had that 5, then the digits would move right 2 places, because I have 100, 2 zeros, right? 10 is 1 place, that's 1 space. Now, think about that with a whole number. If I still took that 5 and I multiplied it by 10, 5 times 10 would be 50. If the 5 was here, right? Oops, if the 5 was here and I multiplied it by 10, the 5 would move this way, and it would be 50. It would move left. So if it was asking about a whole number, 10, you would say that the digits move 1 space to the left when it's a whole number. Again, if it's at 100, you would say that the digits, and I'm thinking about the 5 still here in the ones place, if I multiplied that by 100, that would be 500. So that would mean that the 5 would move 2 places to the left with a whole number. So when you have decimals, your number is moving right, it's getting smaller. And when you have whole numbers, your number is moving left and it's getting bigger. Let's take a look at number 17. We're going to skip number 16 in the practice book and on the test. You can do that for extra credit if you'd like. We have to match the answer with the equation, okay, or the terms here. So if you notice, some of these are similar. These answers are similar, but the decimals are different. So once we multiply, we'll probably just have to multiply 3 times and then count the decimals, okay? So we have 82 times 7/10. I'm gonna multiply 82 times 7, and I will put my decimal in later. 1 decimal place out, so it'll be 1 decimal place in later. 7 times 2 is 14. 7 times 8 is 56. 1 more is 57. Okay, so it looks like it's gonna be one of these answers. I had 1 decimal out, so it's gonna be 1 decimal in. So A matches with that. Also, I see this one, okay, same numbers, different decimals, and I see another answer that's 574. So I'm not gonna do the math for that. That's C, okay? A little trick there. Let's take a look at this, 6/10 and 92. I'm just gonna multiply 92 and 6. I'll worry about the decimal later. 1 decimal place out, so it'll be 1 back in. 6 times 2 is 12. 6 times 9 is 54. 1 more is 55. Okay, so we have this and this one that it could be. It was 1 decimal out, so 1 back in. We have 55 and 2/10, which is right here. So that is B. And I see that I have these 2 numbers here again. So this one must be E, okay? My last one is 74 and 8. So I'm gonna, again, ignore the decimals and just go 74 times 8. 1 decimal out, so I'll do 1 decimal back in. 8 times 4 is 32. 8 times 7 is 56. 7, 59, 3 more. Okay, 1 decimal out, so 1 decimal in. 59.2 is D, which means F must be this first one, okay? So when you get to this problem on the test, remember, look for those similar terms and you can do less multiplying, okay? Okay, for number 18, we have a walking stick, and the walking stick is 2.5 times longer than a praying mantis. So if the praying mantis is 10 centimeters long, how long will the walking stick be? Well, it's 2.5 times longer than the walking stick. So I just have to multiply these 2 numbers together. I'm going to ignore the decimal. And I'm just gonna say 25 times, I'm gonna ignore the 0 too. 25 times 1 is 25. Add a 0 at the end. Took 1 decimal out, 1 decimal in. So it looks like it's 25 centimeters for the walking stick. Let's take a look at number 19. It says when you multiply by 100, each digit shifts to the, so we're thinking about a whole number 100. And in number 15, we talked about this a little bit. When you're multiplying by a whole number, your digits will start to move to the left because the number is getting greater, it's getting bigger. So they move to the left. Now, if you're doing 100, you're going to think about how many zeros there are. There's 2 zeros, so it will move 2 places. Okay, for number 20, we have this multiplication problem, and we have to explain how we know our answer is reasonable. When you see the word explain, you know you're going to have to write something down. And when you see the word reasonable, you know that you are going to have to round, estimate, okay? So the first thing I'm going to do is multiply and get an answer. 8 times 2 is 16, 8 times 5 is 40, one more is 41, 8 times 7 is 42, 43, 44, 45, 46, 8 times 7 is 56, 56 plus 7 is 7, 5, 9, 61, 62, 63. Okay, so we have 63,616 is our answer. Now we have to figure out how we know that this is reasonable. We could say that 7,950 would round to 8,000. It's very close to 8,000. And 8, we could leave 8 because being that I rounded that to 8, we can just leave that at 8 and know that 8 times 8 is 64 and then add 3 zeros. And those answers are pretty close. So we know our answer is reasonable because we took the really large number, rounded it, kept that one the same, and the answers were similar. For number 21, we have to find the answers that are correct. So I'm going to take a look at 6 times 1 and add 2 zeros. 6 times 1 is 6, 2 zeros is 600. It was 2 decimal places out, so 2 in. That doesn't seem correct. A is not correct. I have 300 times 1/10, and I know that when I multiply by a decimal, 1/10, that the number becomes 1/10 small and the digit moves to the right and it would move to the tens place, so B is definitely correct. I don't have to multiply to know that one. Same with this one, 20 and 100th, so that means that my number should get smaller by, the 2 should move 2 places because it's in the 100th place. And if the 2 is in the tens place and it moves to the 1, 2, that's correct too, because that's in the 10th place. It moved 2 spots over. And with this one, 9 times 1/10, well, I know that my decimal's there, and by 1/10, the digit would move 1 place over, so be in the ones place, and that is not correct. So you could multiply these out, or you could just think about how the digits move when you're multiplying by a decimal. For number 22, we have Eva, and she is working as a lifeguard. She's earning $16 an hour, and she's going to work for 28 hours. So how much money is she going to make? If she's working 28 hours, making $16 an hour, this is a multiplication problem. Hint, this whole test is multiplication, okay? So when you see 2 numbers, you're just going to multiply them together. I will take 6 times 8, that's 48. 6 times 2 is 12. 13, 14, 15, 16. X's and O's, don't forget. 1 times 8 is 8. 1 times 2 is 2. Add these up. And I should get $448 that Eva should make. It says show your work, so this is our work. Okay, for number 23, kind of similar to number 22, we have Mr. Clement, who's measuring 29.7 grams of sodium chloride for 7 lab groups. So how much sodium chloride does he have altogether? Again, another multiplication problem. Don't worry about that decimal, 1 spot out, it's gone, we'll put 1 back in. 7 times 7 is 49. 7 times 9 is 63, 64, 65, 66, 67. 14 plus 6 is 20. And we went 1 decimal place out, so 1 decimal place in. Looks like he has 207.9 grams of sodium chloride. For number 24, it says when you multiply 24 and 7/10 by 1/10, is the answer greater than or less than 24 and 7/10, the original term you started with? And we have to explain our thinking. So when we have a number that we multiply with a decimal, then our answer is going to be less than. We should first answer less than. It is less than, and we're going to write because. Explain means you need to add the word because. It is less than because, and there's a couple of things you can put here. You can say when you multiply by 1/10, you know that the digits shift to the right because they become smaller, okay? So it is less than because when you multiply by 1/10 or 1/10, we're doing the same thing, the digits move to the right and get smaller, okay? You can also say, I'm not going to write this down, but you can also say when you multiply by 1/10, that's the same as dividing by 10. You're cutting things up into 10 different pieces, and you're taking what's 1/10 of it, okay? So when you divide, you know that your answer will get smaller. Again, your digits will move to the right.